All right, let's start with problem number 25 from our Model Test 2 review problems, all about logic. Number 25 and 26. For each statement, we're supposed to write the converse, the inverse, and the contrapositive. So if you'll remember, the converse is where you reverse the statement. So if it's if P then Q, then you do if Q then P. On the other hand, the inverse keeps the order the same, but you negate each statement. So if not P, then not Q. And finally, the contrapositive does both. We flip it and reverse it. So you change the order and you make both statements negative. And the contrapositive is actually an equivalent statement to the conditional, the if-then statement. Whereas the converse and the inverse also have the same truth value, and they do not mean the same thing as the original statement and the contrapositive. But here, let's start with the converse. So first of all, here's what I need you to think about. I need you to think about this in terms of P and Q. So if a picture paints 1,000 words, that's your P, then the graph will help me understand it. That's your Q. So if I'm supposed to find the converse, I'm supposed to reverse this. So if the graph will help me understand it, then a picture paints 1,000 words. So there we go. If the graph will help me understand it, then a picture paints 1,000 words. So there's your converse. Now let's talk about the inverse, right? So the inverse, again, if P, so this is your P statement, and then this is your Q statement. Now to find an inverse, I keep the order just as it is, but I negate the P and the Q. So I say, if not P, then not Q. Oops. How about that? Not Q. There we go. So that's what I'm trying to do. So I keep the order the same. If a picture does not paint 1,000 words, then the graph will not help me understand it. Those are pretty easy to negate with just the word not. So here we go. If a picture does not paint 1,000 words, then the graph will not help me understand it. Now the contrapositive, the fun one, and in the end, the statement that we built for the contrapositive is going to have the same meaning as the original statement. So we're supposed to do both. We're supposed to reverse the order and negate both of the statements. So see if we can do that in our head. Let's reverse the order. So if the graph will not help me understand it, then the picture does not paint 1,000 words. And typed up, here we go. If the graph will not help me understand it, then a picture does not paint 1,000 words. So your converse, your inverse, and your contrapositive. And you really just have to know those. Converse is like reverse. Inverse, you're flipping the truth value of both of your statements. And the contrapositive, you're doing both. You're reversing and you're negating the truth value for both statements. So let's try this again for 26. But look, for 26, we're actually given symbols. And so I'm supposed to find the converse, the inverse, and the contrapositive. So these I don't have typed up because I figured we could pull this off with just a pen. So remember the converse, we change the order. So first I'm doing the converse. And so this is your if and this is your then. So if I change the order, I'm going to have Q and R implies not P. There's your converse right there. Now for the inverse, I'm supposed to keep the original order but negate both of my statements. So I keep the order, so not P, that's fine, that will just be P, implies not Q and R. Now that can be simplified, and if it can, you really should simplify these statements. The only thing we're not simplifying on this test are the circuits. I'm not going to demand that you simplify circuits, but these you're capable of simplifying. So not P we know is P, right? And then not Q or R is fine, but notice, look, it says use De Morgan's laws as necessary, and here we need to use De Morgan's laws. So that's going to be not Q. Remember what happens when you distribute that negative, and really distributing is a kind of, I'm using that loosely. That's not really what that's called. It's called De Morgan's law. But what happens is your and turns into an or. And I need parentheses around that because I'm just not doing if P, then not Q, or not R. It's if P, then that entire statement. Follow? Okay. Now, next, let's try the contrapositive. So my last line is going to be the contrapositive. And remember, for the contrapositive, I'm supposed to spell it right for one thing. Contrapositive, I-V-E. There we go. All right, so there's my contrapositive. Now you're supposed to change the order and negate both statements. So I go back to my original. I'm supposed to negate not Q or R. And then I'm changing the order also. So not P. Right? So in other words, you take the inverse and you change the order. Now, we've already handled this using De Morgan's law. So that is not Q and not R. Need that in parentheses though, because it's if all that. Then not P is just P. And then that's my final result for that one. So converse, inverse, contrapositive. Okay, so we're supposed to use an Euler diagram to determine whether the argument is valid or invalid. Look, that my Microsoft Word didn't appreciate an Euler diagram, but that's actually correct. Now, all members of that athletic club save money. Don is a member of that athletic club. Don saves money. Remember, the Euler diagrams are the circles. And so if we can show just by setting up circles correctly that this is a valid argument, then we can. And these tend to work with more basic arguments. They tend to work with when you have quantifiers like all members. There we go. And that's when we know we can use an Euler diagram. Now, direction-wise, I will ask you to use an Euler diagram, and that's how you know you should use one. But let's set up a circle or circles for all members of that athletic club save money. So what's the biggest circle? Oh, let's draw a circle. There we go. So what's the biggest circle? It's actually save money. And it tells us that all members of that particular athletic club save money. So the members fit inside of the circle of people that save money. And I should say members of that athletic club, but I don't want to write all that. Now, if we keep going, we know that Don is a member of that athletic club. So Don would fit in here, often denoted as X. X is Don. Of course, I find nothing wrong with just writing Don in there. Can we say from our picture, which you got to make sure it's drawn correctly, that Don saves money? Sure does, right? Don is a member of the athletic club. All members of athletic clubs save money. Therefore, Don saves money. So this is what we would call a valid argument. And it is shown valid because our Euler diagram represents the fact that Don is on the inside of saving money. All right, number 28. 28 gets fun. So match each argument in parts A through D in the next column with the law that justifies its validity or the fallacy of which is an example in choices A through F. Now, to pull this off, we need to know what in the world is modus ponens, modus tollens, reasoning by transitivity, disjunctive syllogism, fallacy of converse, and fallacy of the inverse. We need to know these arguments. So I've pulled up the information from section 3.6 that tells you all about these arguments. We have to start here. So notice I have the fallacies first. Fallacy of converse, notice here low at the bottom, if P then Q, and Q implies P. Okay, so if we find that we have that argument, it would be false because this is fallacy of converse, whereas fallacy of inverse, you see if P then Q, and not P implies not Q. On the other hand, valid arguments, the modus ponens, if P then Q and P implies Q, it's true. We have proven those in the video for section 3.6. We went through each one of these examples, at least I think we did, and proved either it was a fallacy by using a truth table or it was a valid argument by using a truth table. Okay, so what we need to do is when they give us an argument, we need to figure out which type it is, and then we know it's either true or a valid, it's not true, but a valid argument versus an invalid argument. So let's look at example A and see if we can classify which of these particular arguments, types of arguments it is, and then go from there. All right, so if he eats liver, then he'll eat anything. And we're talking about he eats liver. Does that mean he'll eat anything? Now, you can just think about it real hard and see if that makes any sense. But if we can prove it, because we classified it as one of these 5 things, or 6 things actually, then we know that it's a valid argument. So let's just see what we can do. So if he eats liver, let's call that P. You want to? So if he eats liver is P, then he'll eat anything, that's Q. He eats liver is back down here to P, he'll eat anything is Q. If we write this, this is if P, then Q, and then below that is P, and that implies Q. What do you think? Do we see that? So if P, then Q, below it is P, Q. Look, that's the very first one. That's modus ponens. And if we know it's modus ponens, we don't even have to do a truth table for this, although we could, but that's not what they asked us to do. We know that it's valid, and it's valid because it matches with the modus ponens. See how this works? Okay, let's try the next one. Okay, so example B, if you use your seatbelt, you will be safer. You don't use your seatbelt, therefore you won't be safer. Okay, don't be concerned about thinking through this. Let's just label P's and Q's and see if it matches one of these arguments, whether it's a fallacy or it's a valid argument. So if you use your seatbelt, we're going to call that P. You will be safer. We're going to call that Q. You don't use your seatbelt. That's not P, right? You won't be safer. That's not Q. So if I write that down, that's if P implies Q, along with not P, and the outcome, uh-oh, I've got an error. You will not be safer. I'm sorry, I wrote not P down here. You might be hung up on that. That's not Q, right? Because we said Q is you will be safer. You won't be safer is not Q. Now, do we see that argument anywhere? So, P implies Q, not P implies not Q. How about that? Fallacy of the inverse. Okay, so this matches with F, fallacy of the inverse, and we know that this is a fallacy. It is not a valid argument. Okay, so 2 things we had to know. Really 1 thing we had to know, because this tells you whether it's a fallacy or it's a valid argument. But I want to make it clear. This is definitely a fallacy. Why? Because it is a fallacy of the inverse type. So let's try it again. So example 28C, again, what are we trying to do? We're trying to figure out which of these 6 arguments we have going on here. If it's one of the first 4, it's a valid argument, but if it's one of the last 2, it's invalid, or a fallacy is the name of that. And we're not trying to find if it's true or false at all. I just need to know, is it a valid argument and an invalid argument, and which of these 6 types of arguments does it match with? So if I hear Bojangles, I'm going to call that my P statement. I think of her. That's my Q statement, right? If I think of her, okay, that's going to be, remember, that's already my Q statement. I smile. That's something brand new. Let's call that R. If I hear Bojangles, remember that's P, then I smile, that's R. Now let's write down exactly what we have. So we have if P, then Q for our first premise. Our second premise is if I think of her, that's if Q, then I smile, implies R. And my outcome is if P implies R. Now, first of all, we're looking for something with P, Q, and R, and that rules out the 2 fallacies. It rules out modus ponens, modus tollens, and disjunctive syllogism. I said that wrong. But reasoning of a I can't speak. Reasoning by transitivity, okay, is our next one. So P implies Q, Q implies R, P implies R. Notice that's exactly what we have. We're not just looking to see if it has P's, Q's, and R's, but it does have to be the same type of argument. And this is definitely reasoning by transitivity. Okay, and what do we know? that those are valid. I have one more. Let's try it. Okay, so this is our last one of this type where we need to match. So the first thing I need is I need to write down what this argument is actually saying. She sings or she dances. Okay, so she sings, I'm going to call that P, or she dances, dances is Q. She does not sing. Okay, remember P is she sings, so she does not sing is not P. She dances is Q. So let's write down exactly what we have. She sings or she dances. Now notice this is not an if-then. She sings or she dances. This is P or Q. And then our second premise is not P. Does that imply Q? Now, to do a truth table for this, what we'd have to do is we'd have to do P or Q and not P. Write that as the antecedent. So that would be an if P or Q and not P implies not Q. And do the truth table for the whole thing. But if we can see it as one of our arguments down here, then we don't have to do all that. Okay, now notice it's got P or Q. Oh, you know what I did? I made a mistake. I noticed it because this didn't match this disjunctive syllogism. But look, I don't have this right. I wrote down not Q, but we have Q, and it is just Q. So it does match exactly now. We got P or Q, and not P implies Q. So this is disjunctive syllogism, and there we have it. And we know from that that this is a valid argument. Why? Because disjunctive syllogism is in the valid argument forms. We've already proven that that's a valid argument, so we don't have to do the truth table again. Of course, unless I ask you to. Okay, so we're supposed to use a truth table to determine whether each argument is valid or invalid. So this one may or may not, and you probably look at it and it doesn't fit one of those already proven valid arguments or invalid arguments. So we need to just do this one from scratch. Okay, now again, how do you do this? You're supposed to write each premise, okay, down and put an and statement in between them. So we have, make sure my pen is working, we have not P implies Q, or if not P, then Q, and the next line, Q implies P, okay? Now we write all of this as an if-then statement. So it's if this, then the final statement, P or Q. So we need to do a truth table for this entire statement. So you basically write each line with an and then put big brackets around that and say, if that, then your outcome, P or Q. Now, can we do that? Sure we can. First of all, we just have P's and Q's. So the number of rows is going to be 2 to the second power, which is 4, plus the header. So when I pick mine, I'm going to have 5 rows. Now, what about the columns? Well, we need a P and a Q, like always. Okay? Notice the only negation I have is not P. I don't have a not Q, so I'm only going to do not P. And then I need to do my parentheses. So I have a not P implies Q. And then I have another column for Q implies P. And then another column for that entire and statement. And then finally, a column for the whole thing. So that's 1, 2, 3, 4, 5, 6, 7 columns. So to get this started, I'm going to build a table that has 5 rows, which is our 4 rows that are required plus a header for me, and 7 columns. So bingo, I have 5 rows and 7 columns. So what goes in my each column header? I need a P, just like I have listed above. Q, not P implies Q. And then the other premise, Q implies P, and then those two together, so I'm just going to put and then finally the if-then statement at the end. Okay, and I'll make it clear what we're doing as we go through. So, the truth values for P and Q, remember we split it up as true, true, false, false, and then you alternate true, false, true, false. And that gives us every combination of the truth value for P and Q. Now the next thing that I want to do is whatever it says. It says not P, so I'm going to look at my P column and negate it. So not true is false, not true is false, not false is true, not false is true. And then I've got not P implies Q, so I'm going backwards here. So not P implies Q, false implies true. Remember, is true, because in an imply, if you start with a false, it's true. False implies false is true. True implies true is true. True implies false. That's the only one that's false on an if-then, if you start with true and you end up with false. Okay, we've done that statement. Now I'm doing Q implies P. So I'm doing Q implies P. So true implies true is definitely true. False implies true is true. If you start with a false, it's always true. But true implies false is false. So our third line is false. False implies false is true. If you start with a false for an if-then, your answer is true. Now we're doing an and statement, but look at what the and is. It's between the not P implies Q column, we have that, and Q implies P column. So I'm looking here and here. Now, when you do an and statement, the only way it's true is if both are true. So both are true there. Both are true on the second row. The third row, that is false, right? Because true and false together is false, and same with the fourth row, false and true together is false. Finally, I'm doing an if-then statement. If-then between what? So it's this whole line here, which is just our and statement we just did, and that implies P or Q. Do I not have a column for P or Q? I don't. Look, I left that out. So I'm going to have to change things just a little bit rather than redoing this whole video because things happen. I need a P or Q column right here. Because again, I forgot to do that one. So I've got my P or Q column. I'm going to write it where we can read it now. And then in the last line, I'm going to do my if-then. So let's go back and do our P or Q column. So I'm looking at P or Q, here or here. Remember, or means either one of them is true, the whole thing is true. True or true is definitely true. True or false is true. False or true is true. The only one that's not true is false or false. So that's false. Now I'm doing my if-then statement. So I start with my big and statement here. Does that imply P or Q? Okay, and that should have been 8 columns, by the way. But that's okay. We just added a column. So I'm going from my big and statement, which is my next to the last row. Does that imply my forgotten statement, P or Q? So true implies true is true. True implies true is true. False implies true is true. Remember, for an imply statement, if you start with a false, it's true. False implies false is true. Again, if-then statement, if you start with a false, it's true. If you start with a true, it depends on if the other side is also true, and it is. Look, what does that mean? That means that this is a valid argument. So, in the end, if you get all trues, that's called a tautology. But what the tautology is the argument. In other words, premise 1 and premise 2 implies the conclusion, which is P or Q. And it does. So this is a valid argument. You want to try this again? Let me see if I can get my rows or columns numbered correctly. Okay, so we're just trying to determine if the argument is valid or invalid. And notice we have an R, a P, and a Q. So this is our truth table that actually has 3 components. So again, notice it's a P, a Q, and an R. Okay. Now to match the book, they tend to do theirs in alphabetical order, so I am as well. Notice that's all I have. I have R and P, it's listed. Q and P is listed. R and P. I'm making sure I'm not leaving anything out. Yes. Okay. Now, what else do I need? Okay. So I need a P, Q, and R. Notice there are no negations, so I'm not going to do a not P, a not Q, or a not R. So now I'm ready for parentheses. So I need to do R and P. I need to do R or Q. I need to do Q and P. And I need to do R or P. This is a big one. But I'm not finished because I haven't even built my premise and conclusion if-then statement. So remember, you write your premise 1. I'm just recopying that. So that's R and P implies R or Q, and premise 2, Q and P. Okay, so we have this and this, and then that implies R or P. Okay, so this is what I'm trying to figure out. Now, let's look at our columns. I did everything with the parentheses, but I haven't done the R and P implies Q, so I need that if then there. And then I have to do that and Q and P, so that extra and then finally that whole thing implies R and P, so another if then. This is big. So the number of rows is going to be 2 to the third, which is 8, plus one more for my header, so I need 9 rows. Really 8 rows if you were answering this question in the book. The number of columns was where it got really confusing. But we have P, Q, and R, that's 3. R and P makes 4, R or Q makes 5, Q and P makes 6, R or P makes 7. This if then here makes 8, and then the overall premises make 9, and then the final if then makes 10. So it looks like 10 columns to me. I counted that quickly, but the good news is we can always add if we need to. So let me build a 9 by 10, and then we will see if we can fill all this information in. Right, all right, here we go. So I need, remember column headers, I need a P, a Q, and an R. And then I need an R and P from this very first parenthesis statement. I need an R or Q from the second parenthesis statement. If you want to go ahead and do the if-then right there, you can, so they're next to each other. I need a Q and P from our second premise. And then I need an and over all and from combining these two together. That's not going to fit, so I'm just writing that circles. Okay, I need an R or P. I don't have that anywhere. And then I'm going to need the final if-then statement that I'm going to put right there. I know this is confusing. I'm going to try to make it clear as we go through each thing. So P, Q, and R. Remember how you do this? You take your 8 rows, you divide it in half. So I have 4 trues, and I have 4 false. Then column Q, I split my 4 in half and do 2 trues, 2 false. And once again, 2 trues, 2 false. And then I split my 2 in half and it's 1, so I alternate 1 true, 1 false, 1 true, 1 false, 1 true, 1 false, and then finally 1 true, 1 false. And this is every combination that we could have for truth values for P, Q, and R. Now I'm going to do R and P, and I got to be really careful, and that came from here, right? R and P, that's the one I'm working on right now. So R and P, I'm going to do this in red. I'm looking for my first column and my third column, and is only true when both statements are true. So the first row is definitely true. The second row is false because I have a true and false. I have a true and true, so my third row is true again. A true and false is false. A false and true is false. A false and false is false. A false and true is false. And a false and false is false. Remember, for an and statement, they both must be true. So that's only the first and third. Now, R or Q. So here I am now. R or Q is right here. And so that's what I'm working on right now. Okay. Now, R and Q are next to each other. That's helpful. And so I'm working with the second and third columns, and it's an or. So if either one of them is true, I'm true. True and true is true or true. True or false is true. False or true is true. False or false is false. It's the only time we're false. True or true is true. True or false is true. False or true is true. And once again, false or false, that's the only time you're false is when both are false. Now I'm doing the if-then statement, okay? Not the big one. I'm doing the if-then statement that's right here, okay? That's this if-then statement. So I'm doing R and P or R or Q. In other words, it's my 2 red columns that I've got going on. So R and P implies if then or Q. If I draw an arrow, we're looking at that situation right there. That's my if then. So true implies true is true. False implies true is true. If you start with a false, it's true. True implies true is true. False implies false is true. False implies true is true. False implies true is true. False implies true is true. And false implies false is true. So the only time an if then statement is true is if you start with a false or you have a true and true. And that's what we had all the way down, either a true and true or you start with a false. We didn't have a true and false, which makes it false. Now our Q and P column, that's our second premise right here. I'll change colors on you just a touch. How about pink? We're right here. This is Q and P, and that's this column right here. Why am I doing that? Because I need to do something for my second premise. So let's fill in the information. Q and P. So I'm looking at my first two columns and I'm just doing an and. Q and P. So true and true is true. True and true is true. True and false is false. Because we're dealing with and, they must both be true. True and false is false. False and true is false. False and true is false. False and false is false. And false is false. Because and statements are only true when they're both true. So we got that. And notice here I've got another and statement. Now what and statement is this? This is the and statement. That is this whole expression when we put our two premises together. R and P implies R or Q. We did that already. Okay, that's this column right here. And Q and P. Okay, so that's this statement is that whole thing. And again, it's the if then and the Q and P. It's these two guys that are right next to each other. It's this one and this one. Okay, so let's try that. So it's and. So we've got true and true is true for an and. True and true is true for an and. True and false is false. 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 There we go. Now we've got R or P. Now this is just random R or P all by itself, and that is our conclusion at the bottom. Okay, we're not finished. We've got one more line after this, but R or P. Now I'm going back to way at the beginning, R or P right here, right? And right here. So the order you do it in doesn't matter. So I'm looking at true or true is overall true. True or false is true. True or true is true. Again, first and third column, true or false is true because we're doing or. False or true is true. False or false is the only one that's false. False or true is true, but we do have another false or false down there. So when I say the only one, I meant out of an or statement, not out of these rows. Finally, we're taking our entire R and P implies R or Q and Q or P. That is, let me erase a little bit of, well, I don't want to. That is this statement right here. The big and statement implies R or P. So we're arrow over, we're doing like this. So the big giant and statement implies R or P. Now an implies means if you start with true, it has to be true, or if you start with false, it is true. So true implies true is true. True implies true is true. If you start with a false, like we're doing on the third row, implies true, it's true. Start with a false, 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 it's true. Look, we got all trues, which means this big long statement that we found is a tautology, but what it means when you're testing arguments is that this is a valid argument, and that was a big problem, but a good one. Now we're very close to finishing our review, so we have a circuit, and I just want this written in symbols. Now these are the problems in the book that ask you to write it in symbols and simplify if possible. But the simplifying to me is a little above and beyond the scope. Some simplify just fine and they would be great, but some are more complicated. So if I can just get you to write this in symbols, I am a happy camper. So notice what happens. As soon as we come into the circuit, right here we have a choice. We can go up or we can go down. Notice the or statement. So right off the bat, I'm dealing with an or statement, and that's going to go in the middle. In the middle of what? Well, if we go this path, notice that's an and statement, because if they're in line with each other, that's an and. But I need it in parentheses, because one of the paths is P and Q. Or you could go down to the bottom path, which is another and statement. I'm going to put that in parentheses. That's P and R. And that's it. That's the whole thing. So right off the bat, our big decision is an or. That's this middle or. Now, if you go up at the top, you have to go P and Q, because you can't escape Q. If you go P, you have to go Q. That's why that's an and. It's in parentheses because that separates it from the other or trip, and that trip is also an and because they're in line P or R. I hope that made sense for you. And this problem to me is very similar to the last one. We come straight in and we have a choice. We can go up or we can go down. So I have a big or statement in the middle. If we go up, I just have this single decision here, so it's not P or. But if we go low, then you have two things you must go through. This is an and statement, and that's going to be in parentheses because it's all by itself a path. So that's Q and not R. And then you go out either way. So you either go not P and you go out, or you can go Q and not R and go out. And that's your final answer. And for our last practice problem, we're to draw a circuit for the statement. So notice this is a whole separate decision itself. Notice the brackets. So the big overall decision is right here. So we start with P. So we come in and then we have a P right off the bat. Okay, so we have a P. I'm just going to call that switch P. But then after P, you're looking at just this statement and it's an or statement. So I need to branch up and I need to branch down. Now inside this or statement, I have another or statement. So at the top, I got to branch again and I can go Q or R. So there's my Q and then there's my R. And then it can come back down. All right. And then here, notice that's an and. So then I can go Q, but since it's an and, it's lined up. And then we can come back and complete our circuit, and then we're out the door. So make sure that makes sense. You have a P and. Okay, so you have to do this. And after that, you have a choice. You can go up into a Q or R, or you can go down here into a Q and R, and then reconnect and leave. I hope this makes sense. If that is not clear, please let me know, and I'll try to do a better job of explaining it for you. I hope you have a good day. Let me know if you have questions.